In the previous videos, we came up with kind of an intuitive understanding of what a function is, and then explored three different ways that functions can be represented in their standard form, in terms of a table, and in terms of the graph. And in each of those three different ways, what I wanted you to be able to do is answer input and output questions. So understand, just based on the notation that you're provided with, whether you're being told the input or whether you're being told the output, and then whichever one you're given, be able to figure out the other one, regardless of whether your function is given in the standard notation or a graph or a table. Really, that's the meat of this section. That's the most important stuff to be able to do. But there are some other things I want to talk about. They're kind of less important, but I'm going to make some quick videos about them. They should be a little bit shorter. And the first of those kind of leftover things is going back and forth between the two. Right? Maybe after having answered these input and output questions, you have some preferences. You kind of like the graphical form when you're given the output and looking for the input, but you like the equation when you're going in the other order or something. Maybe you can make an argument about, at this point, about advantages and disadvantages to equations versus graphs. Really, all I want to show you in this video is how to go from the equation to the graph. Eventually in this class, we'll be able to go from the graph back to the equation, but that's a little bit beyond where we are right now. So for now, suppose we were given this function f of x equals x squared minus 2x minus 8, and we wanted to know what its graph looked like. Well, one way you can get there is by making a table. So we kind of get to use all three of the different forms that our functions can be given in. From the equation, we're going to create a table, and then from that table, we'll create a graph. How? Well, the idea is all a table is a listing of inputs and their corresponding outputs. And we know how to figure out outputs for any input just going from the equation right here. What I should write in this spot in my table right here is f of negative 3. In other words, what comes out of the machine when I put negative 3 into it? Well, it's easy to figure out f of negative 3. All I have to do is copy this blueprint right here and change all the x's into negative 3's. So I would get negative 3 squared minus 2 times negative 3 minus 8. And since negative 3 squared is positive 9 and negative 2 times negative 3 is positive 6, I get 9 plus 6 minus 8. So I get 15 minus 8. I think I end up with 7. There'll be a 7 in this spot in my table. And I can do that same thing for any other spot in my table. Don't worry, I'm not going to work through all of them, but just show you one more maybe. What if I wanted to know what goes right here? Well, what goes right here is f of negative 2. F of negative 2, I just copy this blueprint, changing all the x's into negative 2's. So negative 2 squared minus 2 times negative 2 minus 8. Let's see, I have positive 4 plus 4 minus 8. I think we've already done this calculation. I get a 0. And if I felt like it, I could continue in this manner to fill out the rest of this table, and I'd get all of these values here. Going from an equation to a graph is a little bit tedious. I mean, it's really a whole bunch of the input-output questions that we explored in the last video, but it's not really anything all that interesting. It's just sort of busy work to fill out this table. Once you have the table, you can go from the table to the graph pretty easily. The fact that negative 3, 7 is an input-output pair, in other words, when I put negative 3 into this machine, 7 comes out, means that the point negative 3, 7 must be on the graph. Negative 3, 7 is right here. Similar logic, because negative 2, 0 is an input-output pair, the point negative 2, 0 must be on my graph. And I can do that same thing for each of these other points. Negative 1, negative 5 is on my graph. 0, negative 8 is on my graph. 1, negative 9 is on my graph. 2, negative 8 is on my graph. 3, negative 5 is on my graph. 4, 0 is on my graph. And 5, 7 is on my graph. At this point, I have to let you in on a little bit of a secret. We don't know how to connect all these different dots. You might guess to connect the dots like this, with this sort of U shape, this parabola, if you've heard of that term before. And that is the correct way to connect these dots, but we don't know that at this point in the class. At this point in the class, we just know that there's some line that goes through all these different dots that we had pictured, and maybe this is the most logical way to connect all those different dots. It ends up being the right answer. We just don't know that yet. So I guess what I really should have said is, at this point in the class, we can't go from the equation of a function to the graph of the function, but we can go from the equation of a function to a pretty good guess of what the graph of the function looks like. And the way we accomplish that is by filling out a table where we kind of arbitrarily just pick some input points. It often makes sense to pick whole numbers here, keep track of their corresponding outputs, and then put dots in those spots on the graph. That's it.